Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life.
Welcome to the Huberman Lab podcast, where we will discuss science and science-based tools for everyday life. Today we are focusing on a system that is consistently active, but almost never noticed. It runs in the background, moment to moment, regulating your heart rate, your breathing, your digestion, your blood pressure, your pupil size, and your response to stress. This is the autonomic nervous system. Understanding this system is essential whether you're studying anatomy and physiology or simply trying to make sense of your own internal status. Once you understand how these circuits work, you can start to predict and even influence how your body reacts in stressful, calm, or challenging environments. To help us break down, I am joined by Dr. Rachel Morgan, a neuroscientist who studies brain-body communication and autonomic physiology. Her work focuses on how stress and behavior shifts the balance between the sympathetic and parasympathetic activity. Rachel, thank you for being here.
Thank you for having me. The autonomic nervous system is fascinating because it operates continuously without any need for conscious effort. And what's important for students to understand is that this system has two different branches that are always working in parallel to each other. The sympathetic nervous system and the parasympathetic nervous system, which aren't always on and off switches, they work more like two sliders that are constantly adjusting and relating to each other's other levels.
Let's start with the sympathetic branch because that's the one most people recognize. It's associated with fight or flight response, but the phrase doesn't capture the full picture. When the sympathetic system ramps up, your body is preparing for action. Heart rate increases, blood pressure rises, airways open, pupils dilate, blood flow shifts towards the skeletal muscles, digestion slows. Essentially, the body becomes optimized for dealing with the challenge.
Yes, and those effects of the system are produced through a very specific signaling pattern. The preganglionic neurons release acetylcholine, and the postganglionic neurons primarily release norepinephrine onto these target organs, and that neurotransmitter is going to act on adrenal receptors throughout the body, which is going to produce those physiological changes associated with sympathetic activity.
The parasympathetic branch, in contrast, brings the body into a state of recovery. This is rest and digest. When parasympathetic activity increases, heart rate slows down, digestion becomes more active, the pupils constrict, the body shifts towards nutrient absorption, repairing tissues, and conserving energy.
And its signaling is distinct. So both preganglionic and postganglionic neurons release acetylcholine, but the receptors are different here. Now, they have nicotinic receptors that appear at the ganglia and muscarinic receptors that are the target tissues. But this branch originates in the brainstem and then the sacral spinal cord, and that's why we call it the craniosacral division.
An area students often struggle with is the physical layout of these systems. The sympathetic system has its ganglia close to the spinal cord, arranged in chains. The parasympathetic system has ganglia right at or inside the organs they control.
Yes, and that anatomical layout explains so much between their functional behavior. The sympathetic signals can spread widely, where the parasympathetic signals are more targeted. And the adrenal medulla takes us to the next level. It essentially modifies the sympathetic ganglion, and then instead of releasing the neurotransmitters onto a single organ, it releases epinephrine and norepinephrine directly into the bloodstream. And this is going to produce a full body sympathetic response within seconds.
I want to highlight something that often surprises students. The autonomic nervous system doesn't only activate during stress or relaxation. It runs reflexes consistently. The baroreceptor reflex regulates blood pressure. The pupillary reflex adjusts to light. Digestive reflexes coordinate swallowing, peristalsis, and secretion. These reflexes rely on the balance between sympathetic and parasympathetic activity.
And when you understand that the receptors, everything becomes more predictable. So beta 1 receptors in the heart is going to increase heart rate, and beta 2 receptors in the airways are going to promote bronchocondition, and alpha-1 receptors are going to restrict blood vessels. These patterns are going to explain why medication like beta blockers work on the heart or why inhalers work on the airways.
Something I emphasize often is that although you cannot directly control the system, you can influence it through behavior. Slow, extended exhales increase parasympathetic tone. Cold exposure spikes sympathetic activation. Exercise engages sympathetic circuits and improves their flexibility. Sleep and circadian rhythms deeply influences the balance between the two systems.
And I think it's important to note that awareness is a powerful starting point. When you notice your heart rate rising, your breathing is going to get more shallow, your pupils are going to dilate, and your mind's going to begin to race. And you can identify that that's the sympathetic system dominating here. And with that awareness, you can apply tools like controlled breathing or posture changes that can shift your state. Understanding the physiological side of things is going to give you the ability to work with your nervous system instead of feeling like you're at the mercy of it.
For students of anatomy and physiology, the autonomic system is fundamental. It shows up in every organ system. If you understand it well, the cardiovascular system, respiratory system, digestive system, and endocrine system all become easier to make sense of. Rachel, thank you for making this material so clear and accessible.
Thank you, it was a pleasure.
And to the listeners, thank you for your interest in science and science-based tools. Whether you're studying this material for school or simply trying to better understand how your body works, I hope this episode provided a strong foundation. Take care of yourself, prioritize good sleep, sunlight, movement, and deliberate rest. And remember that your autonomic nervous system is working every moment to keep you alive and functioning. I'll see you in the next episode.